Okay, let's see here. I don't know why there is no mobile dashboard for in terms of there's obviously the studio app, but in terms of viewing comments and stuff on a live stream. So instead, I have to actually go into the video itself and hope it doesn't count me as a viewer, because that's cheating. That's cheating. Okay, so someone did ask, essentially, to be more vocal about what I'm doing and why I'm doing it. I used to be like that. I stopped because the people that were watching would get really annoyed with the explanations. But this was before I had this YouTube channel. So I've loaded into a nice simple craft. Well, it's actually medium difficulty, and if I need more practice, I can bump back down to Mercury. That's really easy. But something that I've had plenty of experience with and know pretty much everything about, so we'll sort of see if more talking is preferred, or if you guys just like to watch the flying and none of the explanation. So we'll test it out a bit and see how it goes. So we spawned in a Gemini on a Titan II intercontinental ballistic missile. And the first thing that we're going to want to do is be able to see. So on the top circuit breaker panel, under lights, we've got the cabin light. And now we can come back here and adjust the dimmer as required. If we press M in this simulator, we do get a checklist, which is nice. So we've just completed our interior inspection, overhead cabin lights to on, and the dimmer to max brightness so that you guys can see a little more. And if you guys need me to reduce the brightness, just let me know. Like if anything's brightness washed. So the next thing we need to check, secondary O2 bottle. This one is pretty self-explanatory. It's sort of an alternate O2 bottle system. It's used for EVAs and for ascent in case of cabin pressure issues. Abort handle, normal. And then all circuit breakers except TR256. TR256 is time to retro, 256 seconds. So we'll get our coax control, audio and UHF, UHF relay, tone, TV, HF antenna control, and whip antennas. This all is communications related items. And then we have the electric timer. The electric timer is this thing right here. That's our mission elapse time. We've got our event timer, which is this one here. And that's to allow us to set our own countdowns. Then we have our booster cutoff fuses and our retro, auto, and manual fuses. This controls the logic for what happens when the Titan II is done burning and what happens during retro sequence. ECS indicator lights. This is the environmental control system, and these specific lights are the ones like these. Indicator light test. We'll get that on, and that will allow us to do this thing to see if all the lights work. It's good stuff. Our sequence lights, power and control. This is the sequence lights. This panel here, this vertical array of switches, this is called the sequencer. It sequences the events of the mission. And then we have the parachute control. And that just allows us to push these buttons here. Woo! Big lightning. That was cool. Attitude indicator control. This is allowing the indicate retro attitude button, which we'll get to later. And the landing allows us to play our landing altitude. Boost insertion control. That is going to register the control for separating the spacecraft, jettison the fairings, as well as the logic for the inertial velocity indicators. Again, we're just running through the startup checklist right now. As we get into orbit, we'll talk about these things more. Retro sequence controllers. That allows us to hit the auto retro, manual retro fire buttons. And the landing sequence controllers. That's going to allow us to use these, as well as set the indicator lights for our parachutes. Next thing we need to do is the sequence light test, which I've already showed off, but we'll get a full view of everything. That's everything that's supposed to be on for this one. And then red and greens, we should see parachute lights, these lights here, the abort, IVIs, sequence fail lights, ECS lights, abort, tapeometer, and DCS update, as well as the radar, platform, scanner, and computer lights. I'll leave them on dim because if I go to bright, you can see that they're just really hard to read. So on dim, they're much nicer. Next up, we'll need is the attitude indicator with flight director indicator. And that just sort of turns this ball on. This ball tells us our attitude. Then we've got making sure all of our squibs are safe. Squibs here, they control the staging of the rocket. They're sort of these tiny explosive devices. In Apollo, those are called pyros. Then we have the CP panel. This is the commander pilot panel. So first things first, FDR needs to be set to platform and FDM to rate. So platform will derive our attitude from a set platform. Rate will tell us the rates. We can mix them. We could make it show just attitude. We could have computer control or radar control. And we'll get to all these different settings when we're in orbit. Scale is going to be high for liftoff, and that just affects the how much the needles deflect. Now the overhead panel. These are a lot of our more complex circuit breakers, so you'll have to bear with me on this. We've got a DC to DC converter. This is a really inexpensive way of stepping down voltages to change between lower voltage buses without needing an entire transformer. We've got our beacons, and this is sort of like a transponder almost, if you will. Then we've got our aux receiver, our cryo quantity gauge. So all this is radio. Here's power. Cryo quantity gauge, that would be this thing. Shows our H2 and our O2 levels and pressures. And then we've got the coolant pumps. And this controls the flow of coolant through the system. Before we were on ground support equipment, so we were able to actually turn that pump on without the circuit breakers, but normally that is not possible. TM's AC. This fuse is the conversion between AC to DC power. Or sorry, DC to AC power, so we can power our gauges and stuff. And then we've got our transmitters. Some more radio stuff. We've got our real-time, delayed time, and our standby circuit breakers. We'll get our O2 heater on, but not our H2O heater. So we leave this one off. And then we've got the clock lights and the suit fans. DC to DC converter needs to go to primary. And then our center lights. Let me just check up on the stream, make sure that it's not washed out. It looks a little washed out, so I'll just leave those off. Attitude indicator lights on. That just makes this ball here light up, makes it easy to read. OAM's heater, that's for heating up the OAMS thrusters, which we'll cover in orbit. We've got our evap heater, our coolant valves for primary and secondary, and our O2 rate control. And that allows us to control the rate of O2, this switch here. And then the coolant valves are... Where do those go to again? I forgot. Ah, right. For the radiators. To allow us to control the radiators, yeah. Acme bias. That's the attitude control and maneuvering electronics biasing system. We need this on so that we can use this and this. Acme control. This essentially just tells us, or allows us to maneuver automatically, manually, caging the gyros, things like that. Yeah, roll jets will be yaw. And then we need our Acme controller on so that this thing actually does something. Our ohms control, that allows us to do things like open the valves. And the regulators as well, which regulate the helium pressure, so it keeps the pressure controlled. We've got our RCS squibs, and that allows us to blow the reservoir, or rather hit this and blow the thing, closing the reservoir, so we could use our reentry control system. This setting this squib will blow the ohms reservoir, which we don't want, and then the individual maneuvering thrusters, which control forward, backward, left, right, up, and down, and then we've got our attitude thrusters, which control pitch up, pitch down, yaw left, yaw right, and roll left, roll right. And these are all a part of the OAMS. Acme logic should remain on primary, and our RCS fuses should also be closed. And this is for the reentry control system. Okay, and I believe that's everything for this upper panel. Center panel, all of these should be up. Cabin recirc allows us to recirc the cabin to sort of vent off some CO2, like that. Send it to the air scrubbers. Snorkel, this allows us to essentially breathe outside air, and this is only used for reentry. Cabin vent will decrease the cabin pressure by venting it to space. Allows us to do EVAs and the such. Our water seal is a landing system that prevents water from leaking in through the snorkel. And the O2 high rate recock, that just resets the logic on the high O2 rate. So if we do that, we get the high O2 rate alarm, and we can recock that. At this time, suit fan should be off, coolant fan should be off, radiator will be on bypass, and evap heat will be off, and evaporator will be on max flow. And this controls flow to the radiators and the boiler. Controls our temperature of the spacecraft. Mission timer should be on start. That allows us to count up. H2 vac tank should be closed. I'm not entirely sure what this actually does because it is never flipped normally. TDA rigid control, this is the docking adapter. We can rigidize it, undock, things like that, and those are to be off right now. Cryo, O2, and H2 heaters are to be off until we insert into orbit. Cryo instruments and propellant instruments should be off. Then we've got our UHF transmitter to number 1. Our TR, that's transceiver. Our HF transceiver should be off. The silence should be on silence or off. Keying needs to be continuous, intercom, push to talk. Record should be on continuous. Rescue beacon should be off. S-band should be on command. And a C-band beacon should be on continuous. Calibrator should be to number 1. The standby TM should be on real-time. The primary TM should be on real-time and acquire. Tape playback should be on command. Antenna select should be on reentry, so we're on the reentry C-band beacon now. HF antenna can be off. Number 1 audio switch to UHF. This is all configuring comms so that we have comms with Houston. There is no mission control simulated for Gemini, so it's not particularly important, but it's a part of the procedure, so we'll do it anyways. More important for Mercury and Apollo to get your comms configuration correct. Pedestal, our rendezvous radar will be off for now. Platform will be free, so we'll power it up and make sure that it's free spinning. Scanner off, and our rate gyros go to primary. And this allows us to essentially get our attitude rate, essentially how fast we're moving. And computer should be pre-launch and off. Attitude control platform, and our fuel valves closed. Now the pilot panel. We can get the aux tape on and in auto, and this stores the computer programs on it. So we can load up a program by moving this knob here, and the tape will load that program into the Ferrite memory. Crossover should be off, purge should be off, and fuel cell section should be off as well, as the individual fuel cells A, B, C for both sections off. Crossover is related to a purge sequence. So this is never on until you're purging. Delta pressure indicator should be off. But if you want to know what it does, you're essentially seeing the difference between the O2, like here's the H2 pressure, difference in the O2 pressure. So you're able to essentially, with this system, derive how much flow through the fuel cells and water you're producing, as well as how much H2 you're consuming at any given time. Voltmeter should be on battery C. This is a isolated battery for reentry. It's got to do with the squibs. And this should be set to high. Platform and rate. Alright, the right panel. We've got the aux tape power closed. SEO instruments. This is actually a mistype. It's actually supposed to be sequence instruments. SEO stands for search engine optimization. But this should be sequence instruments. So things like the altimeter controlling when you should deploy different things, as well as in relation to the sequencer here. And then we've got our calibrator power, biomedical instruments, our digital control system, which allows uplinking of telemetry, and our fuel cell O2, H2 regulators and heaters, and the horizon scanner heater. Next up, we've got the radar power, and that's for the rendezvous radar. The attitude control maneuvering electronics inverter, which allows us to convert from DC to AC for the Acme systems. The RCS heaters, which allows us to flip this on and heat up the reentry control system, as well as the tape recorder, which controls the audio in the cabin, records it rather, and the fuel cell control, which allows us to use these actually. And then fuel cell delta P indicator, which turns this on. Again, with FDI, and then AC power will be IGS. So our AC power is powered off of the inertial guidance system bus instead of the attitude control and maneuvering electronics bus. This doesn't power off or on any of these IGS or Acme systems, but they just pull the AC power from that. And then, of course, last thing we need is biomedical recorder controls, and that is everything we need. Bus tie, I believe this allows us to tie squib batteries onto the main bus. Anything else we need? Ah, yes. The Agena control power and control, and the squibs. That allows us to, essentially, the Agena's in remote commands. Allows us to control the Agena from the encoder here. It's good thunder. Is it, southerly? Yeah, I'll keep this open for a little longer. I like the fresh rain smell. Yep, and just make sure that the secondary O2 bottle for the pilot is also on. And then we need to preheat the fuel cells by putting them into warm-up. That is the pre-start procedure. If anyone has any questions, now would be a good time to ask. We've got plenty of time until our battery check. Ooh, that was so loud it picked up on the microphone. Alright, I'm not seeing any questions coming in so far. So I'll move on to the next thing. Battery check. The rest of the checklists are a little self-explanatory from here on out. Like battery check, making sure the batteries are okay. Well, I'll explain the sequence and sort of how the sequence works. So we'll come up to the other seat. We'll time skip down to 50 minutes. Okay, 50 minutes now. For our battery check, all we do is we flip this bus selector to BT, or battery test, and we put one battery on at a time. If we had all of them down to test, if one of them was dead, we wouldn't know about it. So we flip the battery position to down, and the nominal should be 24 to 25 volts. And we do that for each battery. Looking at this needle here. So each battery is looking great so far. And that's how you perform the battery test. And this is important because this is powering us through reentry, which lasts a really long time. So we can move on to the fuel cell check after that. So we'll put this back onto our isolated battery and move on down to 45 minutes. Okay, 45 minutes. So now what we need to do is we essentially just turn the individual fuel cells on in the stack. We don't turn on the section power though, because that would tie the bus. But we just make sure that the production on the individual cells is the same as the batteries. So we click through, black section here is fuel cells, white section is batteries. And the fuel cells are producing the same voltages as the batteries. So that's good, and we can turn these switches back to off. And the next thing we'll do is a squib and abort check. And if you remember from earlier, squibs control the sequencing of the rockets. So when we ditch the first stage, when we ditch the second stage, the adapter, the retro pack, the nose cone, do the parachutes, pressurized propellants, all of that is done through the squibs. So it's extremely important to ensure that the squib bus is actually functioning. Even the abort system relies on this single point of failure. Albeit the single point of failure is extremely reliable, it would be really bad if we didn't test it before flight and had to abort. So once we get down to our 40 minutes, we'll run that squib check. All right, 40 minutes now. We can take this to S1 and then take the squib batteries from the umbilical power to off, and we should see that fall to 0. Now we set all 3 to umbilical, and we should see a rise to 24 volts, which is good. Then we take the first 2 squib batteries off, and we should see a drop to 0. And the squib 2 bus should show 0. Put them both down to umbilical, and we should see a volt on squib 2. And then battery C, we should see 24 volts. Battery C is a bus that can be powered only by 1 squib battery. So it's essentially the backup of the backup. The other squib buses need to have at least 2 in order to have power. Once we've done that, we can come over here and we can request our abort and squib check. So when it comes in, we get the abort light, the proper signals come in, 2 abort lights, that's good, and then the test is completed successfully. Good. Leave squibs to umbilical for now, and we'll bump us down to our T-minus 15-minute full internal power checklist. Any questions up through here? Just tell me if I'm going too fast as well. Okay. It looks like there are not any questions so far. Let's go down to the full internal power. Okay, T-minus 15 minutes, full internal power. We take the main batteries on, squib batteries on, and then we're going to power up the fuel cells. So 1, 2, 3, 1, 2, 3. Section 1 power, Section 2 power. got stable volts, stable flows, stable volts. And now we will switch to internal power. And when we do that, we should see a rise in our fuel cell volts. And that's good. Sorry, not fuel cell volts, fuel cell load. That's good. We're on internal power. The fuel cells will combine hydrogen and oxygen into fresh drinking water and electrical power. Sort of the inverse of electrolysis. If you have to put electricity in to split water, then fusing water should theoretically output electricity, and that's exactly what a fuel cell does. So we are no longer relying on the umbilicals or any ground support equipment at this time. And then are there any questions about the fuel cells or the battery buses? Okay, it looks like not. Then in a few moments, we will begin our full pre-flight checklist. So, computer power up. This is the MDIU, the manual data insertion unit. Turn that on, and then we can turn the computer on. And the computer will run through some preliminary self-checkout. This game does have pretty decent in-game tutorials. They're not the greatest, but they're most certainly good enough to get you in a position to learn. And that's what it's really all about, because you can fly any craft. You can do anything. It's not about... It's like teaching a person to fish. Instead of teaching them one craft, you should teach them how to learn a craft. You should teach them the technical terms and the different techniques for like electrical engineering that will go into making a spacecraft, because between them all, and even on modern craft, it really hasn't changed much. Sure, the panels got a nice face uplift. In Apollo, you got this really fancy digital computer with electroluminescent displays, and on modern craft, you got all these touch screens. But the basic concepts, the squibs, the fuel cells, the solar panels, radiators, all of that, the radios, gyros, all of this is almost exactly the same for every single spacecraft. So once you get the terminology down and you know how to learn how to fly a flying machine, then it's good. And that's sort of what the tutorial does. It's not great at teaching you the individual craft itself, but more so about the terminology and the things that are specific to the game, like the checklists, the key bindings. I will say that the Mercury tutorial, in my opinion, from what I remember, I haven't done the tutorials in years, mind you. It's been like 6 years. The Mercury tutorial, from what I remember, is the best one. And that's one I definitely recommend. I recommend you do all of them, but if you had to do one, the Mercury tutorial is great. And so after this flight, if you would like to see sort of the beginner craft, I can absolutely show that off because it is a fantastic learning environment to learn about gyros and horizon scanners and and that sort of stuff. I hope that answers your question. Okay. Let's do our pre-flight, finish off our pre-flight procedure checklist now. Aux tape, that's on. Boost insert squib allows us to stage the spacecraft. Retro squibs 1, 2, 3, and 4, just in case we need to abort. Those will come in very handy. Primary coolant pumps on the coolant loops, those will come on, and we'll see that the temperature will drop off. Good. Radiator is already in bypass. Suit fans will go to 1 and 2. And dang, that suit loop is uncomfortably hot. Let's just, yeah, let's get that, oof. Okay, that is a really unfortunately hot setting for the coldest it can get, might I add. Oh, there we go. Oh, she's kicked in. Alright. Good stuff, good stuff. Platform goes to free, and the horizon scanner goes to primary. This is very important. It aligns our gyros, so if this piece of equipment is not powered on right at insertion, yeah, we're going to have some problems. And now we just need to do the pre-launch alignment of the platform so that we can get in the same inclination as our docking target vehicle. Alright, it's looking good. Go to ascent, and we don't push start for this. The umbilical disconnecting will trigger that automatically. What we do is insert 72, just in case. We'll hit enter. That will load the ascent program manually, just in case the umbilical doesn't do it for us. Attitude control goes to rate command. And I'll cover attitude control more in orbit, because talking about it now is not as great as showing you. So just, it's rate command. Leave it be for now, and sort of pin that in the back of your mind. Yep, these top 3 need to be open, just in case we abort. And that's it. We're ready for launch. So if there's any last-minute questions about the pre-flight procedures or anything like that, feel free to ask now. Otherwise, I think we'll take her to launch in a few moments. Okay, let's take her to launch. Here we go, T-1 minute. I hope you all are ready. At 30 seconds, the fuel pumps will kick in. Ignition. Power vertical. There we go. Roll program. And roll's complete. The roll program is used to align us to the proper azimuth for launch.
We got a roll program. Roger, roll.
And pitch program.
Good lift, all day. Second hit. Roll is in. We have a pitch program. Roger, pitch program.
As I was saying, the roll program is important because engines back then, the computers were not powerful enough to control them in both pitch and yaw at the same time. So it would create very rapid pulses in the pitch and yaw direction without rolling, which would
50 seconds. You're looking good, 8.
cause problems and of catastrophic proportions. So the spacecraft will roll and then it only needs to pitch. Modern spacecraft don't normally need to do this. Certainly not the Falcon. So I'm not sure why the Falcon still does a roll program. When asked, Musk just said that roll programs are cool. So your guess is as good as mine, but I'm over it. And it got dark really quickly. So what we're looking out for here is just making sure the nav ball makes sense. And we're watching the oxidizer level because when we get to this dash segment, the level sense is armed, and that will control the staging. You can see beautifully the sun over there. And here comes staging in a few seconds. And staging.
Roger, staging.
There she goes. There goes half our rocket. While we're in this view, actually, if you look forward, you can see one of the RCS thruster rings. They're divided into 2 rings, and on this spacecraft, RCS does not control in orbit. RCS is the Reentry control system. For this spacecraft, the OAMS is used to control, and that is the Orbit, Attitude, and Maneuvering System, which is attached to the back of the spacecraft, and we'll get a good look at that very shortly. And we're pulling actually about 1G. It's a pretty good launch. Now that it's a little darker, let's see if this doesn't drown the text out again. And I'll just watch my stream and I'll zoom in. Let's see. The benefits of being on, being able to preview your own stuff is to see if any light configurations make it a little difficult to read on stream because the compression tends to be slightly different. And that looks good to me. When you're in orbit, it's easier to read. On the ground, it was almost too bright, actually. But this is good here. And don't worry about this pitch down. The rocket is finely controlling our orbital insertion, so if we need to raise our perigee without raising our apogee, pitching down is the way to do it. And this whole ascent happens automatically. We can see we just passed at this tick mark. We've got our OAMS to orbit capability, and here we've got the level sense arm and our cutoff very shortly, our booster cutoff, which is these boost insert and boost cutoff circuit breakers over here.
Roger, Seco.
That's it. Now the order of procedures is to jettison the horizon fairing, scanner fairings, and to separate the spacecraft from the launch vehicle. Once that's done, we just need to zero out these numbers, so we'll give a little tap of the, turn on the OAMS power, a little tap of the left L button and the aft N button, and that will control our insertion. And we are perfectly inserted. Yep, we are officially in orbit now. So now we need to do our orbit checklist. And while we're waiting, let's go to catch up. So we'll safe our squibs. Another sequence light test. And that looks good. And now we can close off our secondary O2 systems. Our CTR lights as required, and we already have them on. We could turn on our water heater and our orbital attitude maneuvering system heaters. So, as I said, OAMS controls with these aft thrusters. Reentry control system controls with the fore thrusters. So all attitude and everything made in orbit will be with the aft segment of the spacecraft. And that's one of the things I really like about Gemini, is it's got an emergency system. And it looks kind of very unique. And it's in a 4-stage configuration, just the capsule alone, which is really cool. Acme bias powers primary, roll jets to yaw, we've already done that, drivers primary, suit fan, pumps, antenna select from reentry C-band beacon to adapter C-band beacon. The recorder can go to off. And we could take off our main batteries now, and our squib batteries. Oh, sorry, squib batteries need to remain on. I lied. Right-hand bottle, get that to off. And our secondary O2 system quantity is still good. Voltimeter is on C. Ohms control power off. Yep, so let's get all of this off now. And wait for the horizon scanner to acquire. And that it just did. Fantastic. Right, so let's go over everything now that the horizon scanner has acquired, and we're waiting for the computer to load the next program, which is what this light is. When this light goes out, we know that the computer program is loaded and we can run it. So as I said, OAMS, this controls our orbital position and translation. The platform has several modes. You can cage it to 0. BEF is blunt and forward. This essentially makes the spacecraft point backwards in orbit, if you will. So if we were to go and switch our attitude control right now to platform, we would face backwards automatically. Orbit rate will hold an orbit rate with the Earth. SEF is sharp and forward. It is exactly the direction we are going now. If we thrusted forward, we would thrust posigrade. Use an INS. It uses an inertial reference system. They navigate by themselves. Yes. Well, I shouldn't say that. With reservations. They navigate by themselves with reservations. And I'll go over that in a moment. And of course, we have the next cage option and setting the platform to off. So let's say we wanted to face backwards. We could do BEF. And then we notice that now we're sort of turned around. The numbers are different. If we go SEF, that shows 0. BEF, and that shows 180. We could hit the D key to sort of yaw around if we wanted to, or we can just change the control to platform, and that is automatically going to maneuver the spacecraft to our desired blunt and forward attitude. Yeah, so this uses a horizon scanner to derive the attitude. The Apollo does not, and that's something that I'll go over in the NASP videos. Someone was recommending that I take more of a explanatory approach in the streams as opposed to just flying and you guys watching and I'm not really saying anything. So that's what I'm attempting to do now by just flying a basic craft and getting some more vocal practice in. So essentially finding my voice. So let's go over now, while we've got the time, let's go over the settings. Reentry and reentry rate commands, they're only used for entry. So we'll skip them for now. But pulse, that essentially pulses the thruster one time. Even if you continue inputs, you can hear and see that the thrusters are only pulsed once. And they will not continue to fire, which means we will keep maneuvering. If we go to direct, we are able to continuously fire the thrusters, but it does not stabilize our attitude. So we can hold it down as long as we want. We'll keep accumulating rates forever. And it won't stabilize our attitude after we've finished our maneuver. But if we go to rate command, we can see that the attitude is immediately dampened back to 0, and it does that right when we release. Horizon scanner, not entirely sure what this setting does, because setting it to her orbit rate on here plus platform holds the orbit rate, but if I had to imagine, it's some rate relative to the horizon. So yeah, we could track our booster for a while. Any questions on the platform and attitude control system? Oh yeah, let's get our cryo heaters on auto. Alright, looks like no questions about that. So we will tick time to the 30-minute mark. Oop, and we could see that the computer has actually finished loading the catch-up program. So, one of the things that we should do now is press the C key and circularize at periapsis. Rendezvous, we need to do this because we need to be completely circular for rendezvous for a Hohmann transfer because it's designed for circularity as its principle, as opposed to something like a coelliptic rendezvous, which doesn't need to be circular. The reason we do that at periapsis is because when we're closer to the Earth, we are spinning around it more times, so we essentially are faster relative to the object, even though our ground speed is slower. Kind of trippy to think about. So in space, in order to go faster, whilst you're in orbit at least, in order to go faster towards an object, you must actually slow down. So we'll circularize at periapsis, and
Roger, DCS.
we can see that we get the digital control system uplink, so we can acknowledge the receive of the DCS uplink. And now we can come to the computer here, and we will verify 01 is going to be our ground elapsed time of initiation, and this is in hours and minutes. So 1 hour and 10 minutes, and that's exactly as we have here. So we can press clear. 02 readout. This will be our minutes and seconds. 39 minutes and 24 seconds, which we show here. Clear. 25, 26, and 27 give us our delta X, Y, and Z that will be burning. So if we go to 25, we'll notice 90808. This appears to be really high, but because this computer doesn't have any parity bit like the AGC does, a 9 in the first digit is represented as the minus sign. And 808 is good. So now, looks clear. Go to 26, readout, and that should be 0. And this says -0, which is a valid thing. So if we want to, we could do that and hit enter, and that will display -0. And 27 will be -3. This shows -2, so let's change that. 90003, enter. And that is now keyed in as -3. That's it. Now if we hit core 83, readout, we'll get our countdown. But first, we need to start the computer. I lied. It is not 83. Let me refresh my memory. It's been a while. It is 84. Yes. 84. So here's our countdown to our burn. Instead of sitting here spamming it like this, annoying everyone, we're just going to look at our mission timer, because that's a better indication. Yellow, what's up? What's up? So I'll leave this down here, and I'll sort of make it take up less space. And we'll get prepared for the burn. I'm not going to set the countdown, but I just like to zero this out while we have the chance. And then this is sort of, you just look at it, and it's kind of, I guess, self-explanatory on how to use controls in minutes, 10 seconds, 1 second, and then, of course, off and up or down. A is for auto, which is just to start it after the liftoff is received. So we'll leave that there. And standby is actually start on this thing. It's misleading, if you will. So we'll go to our sharp end forward for this maneuver. So we'll configure the platform to display sharp end forward and the attitude control the platform. And as soon as we open these, the spacecraft will automatically maneuver towards the sharp end forward. Now there is no burn attitude in Gemini. because you have translation on all axes. But it's just recommended so that most of the burn is done in one direction. So there we go. And of course, roll does not matter. We'll put this back to rate command so we could fully dampen that rate out. That's it. Close those valves now. And we'll skip along to the 30-minute mark. Ooh, before that, actually, we can see our suit loop is accumulating lots of CO2. Simply just open the cabin recirculation valve, and we'll vent that CO2 to the cabin, and get some fresh CO2 from the cabin in. Or fresh O2 from the cabin in, not CO2. So, if you ever notice an accumulation of CO2, just open that. And in fact, you can actually just leave this down for the entire mission until EVA. So, time skip right along to the 30-minute mark, because at that point, we need to request the... where is it? Radiator temp check. I don't want to do it, though, because it's a nice reminder. But whatever, we'll have to. It's good. Inlet 12, set radiator to flow. And evap the evaporator boiler. Normal. That's everything. Now we are ready to begin our first burn for our rendezvous. Does anyone have any questions so far? And if your question is, can we do an EVA? Of course we can do an EVA. This is Gemini we're talking about. Its whole purpose was Rendezvous and EVA, so we will be doing an EVA. It's mandatory on every mission that you do an EVA because they are just that fun. Here, we're just going to manually fix our burn attitude ourselves. WASD, QNE, like regular flight sim. Translation is with IK, JL, H, and N, which is a little funny, but you get used to it. Alright, so let's truck right along to that burn. Oh yeah, one thing I forgot to mention. On this spacecraft, H2 is going to be what limits your power. O2 is what limits sort of your EVAs. The power plant does not take up very much O2. But H2, it will take a lot of. So you should be monitoring H2 every once in a while. And if you want to know what your fuel level is, flip this here. You get your temperature and your pressure for the propellant. You also get your propellant quantity gauge here, which is good information. And now we'll finish trucking right along. One hour. 10 minutes. Ew, we passed it. Whoopsies. That's fine. We'll get it close enough. So I just burn to zero these out. There we go. And let's take a look and see if that is relatively good. And we can see we need to sort of thrust in the down direction until we are within 1 nautical mile. There we go, 77.3. Just manually fixing that to compensate for my accidental time-skipping mishap. So once your burn is complete, on catch-up, you should always set the computer to reset mode. Then we'll calculate our rendezvous now.
Roger, DCS.
And that will pop up. If you're wondering what all this information means, we do have data forms for the ketchup maneuver pad. No, not the sauce condiment. So you could sort of fill this in yourself. You got the purpose, the GETI, so you can come in and expand this window and actually just stamp in 0, 0, 2, and this numbers and stuff you could change with the scroll wheel. 3, 0, and then 0, 2, 2, 6, 0, and then 0, 1, 4, 9, 9, and then 5 balls for the other two. Burn time will be 74.94 seconds. And then attitude is not applicable, of course, because it can burn in all directions. Our predicted apoapsis and periapsis after the burn: 0, 1, 6, 0, 9, and 0, 7, 0, 0, 7, 7.2. And that's sort of how these work. So they'll help you decipher this, essentially. When they do read up these burns to you, they're most of the time not going to read out the decimals. So the astronauts would write them down, and they get the translation of the decimals for them. And that helps with knowing how the computer displays as well, because of course, none of these computers have decimals. Let's verify the MDIU data is correct. 230. 02260. 149. Let's go 01499. There we go. 26 should show 0. Good. 27. 0. Good. And that's all we need. Any questions about the pad or anything like that? If not, then let's start the computer up for the next burn. Our burn starts at 2 hours, 30 minutes, 22 seconds. This time, we will not miss it. Okay. Let's be very careful now. 10, 20, 1, 2, and burn. And we essentially just burn to zero these out. It's a pretty nice system. And while we're in our coast, we can set the rendezvous radar to standby, and that'll get it heated up. To right, and just very slightly down. That's it. We can hit reset and copy our circularization at apoapsis.
Roger, DCS.
Same as before. 01 will show 00314. That's good. 02 will show 03043. Good. 25 will show 01483 is what it's supposed to say. So 01483. Enter. 26 is good. 27 is good. That's it. And I just want to check 25 again. Make sure that entered in nicely. Good. And that's expected to occur at 3 hours, 14 minutes, and 30 seconds. Start the computer. That was 3 hours, 14 minutes, and 30 seconds. And while we are in our coast phase, after we let the rendezvous radar heat up for like 15 minutes, oops, did not mean to bump that. While we've heated it up, let's get it on. We can see we've acquired a lock on the rendezvous target. That we'll talk about very shortly. 14 minutes, 30 seconds. Okay. And 10, 20. Ignition. You can see our rendezvous radar is already very much responding. And whilst we're burning, if we ever get such a very big delta V like this, we could actually just bring us a little pitch down. Shorten our burn time, because the shorter the burn time, the more accurate it ultimately will be. And insertion. Now we have officially rendezvoused. Not exactly, but we've got there. So next steps need to happen a little quickly so that we can stabilize our orbit with the craft. So we will reset the computer and we'll begin loading the rendezvous program. We'll get the encoder on, exterior lights to dock, and the docking index, which is sort of like a reference, we'll get that to extend, and that'll pop out for us. Very nice. We'll also get bus arm to dock. And now, let's do something cool. Radar, attitude, and now let's manually center the yellow needles out. This is gonna blow your guys' mind. Because this whole time we've sort of been doing these burns, and it's like we couldn't see the thing, so it's like, how do we make sure that what we're doing is right? We have to sort of just have blind faith in the computer calculations from the ground. But now we are actually completely independent of the ground. Now that we're on radar, we can point straight at the object. And in case you can't see it, it's that thing right there. Looks like a star. In case you can't see it, with the encoder, we've got Agena commands, and we can do a command 2, 5, 1. And there she is. Now that we're looking right at it, we are no longer going to want to control our attitude. Instead, we will do the entire thing on translation, because it will ensure that we do not change our orbit relative to the Agena, which would make us miss the target. So just make sure that when you get to this point, you just point at the Agena once, and if you are no longer pointing at it, fix it with translation, not with attitude control. At this point, you can begin your big thrust forward and let the rate come down. And then I recommend for this that you don't really go over +5. This is sort of the cutoff for a rendezvous. Anything greater than that, and you have to recalculate on the catch-up programs. And then another thing I recommend is that you do not let the range needle touch the rate needle. And that will prevent you from, well, smacking straight into the thing. Just a few tips of mine. Other people may tell you other things, but this has never failed me once. So we'll go low sensitivity now. You can see the different sensitivity effects. On low sensitivity, we can see that we would need to translate a little down and a little to the left. Excuse me, I'm used to inverted sort of plane controls. There we go. Gotta come up. Yeah, so here it's all about the instruments and the window. Making that perfect approach. And we can see that our range needle is approaching our rate needle, so let's slow her down. And we can see that because we're slower speeds, these needles will deflect quite a bit. So we just need to stabilize them again. It's all about keeping things center and never letting that range needle touch the rate needle. So we back it down a little more. We can see we're drifting to the right, and the needles show the same. And drifting down, so we need to go up. And there it is. And we've got some nice flickering to accompany us on today's rendezvous. Good for us. Again, even when you're really close, never let that range needle touch the rate needle. Back it down until you exceed the limit of the range accuracy. Yes, and I don't know what is causing that flickering. Let me see if I can't get? Yeah, it's not something that I could do here. Let's try vertical sync and see if that'll work. And no. No, okay. Unfortunate. Oh, and as we approached, it gets better. Good, 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 good. So again, that, never let it touch. Bring her to 0. And we're here. So if you want to dock, you can run the Rendezvous program. That is an option. And that will sort of get you the correct docking attitude and everything. Otherwise, you can do it visually. That is also fine. It's 100% up to you. Me, I do the rendezvous a little faster than people sort of expect. So I always tend to run them visually. But if you would like to see how the computer would respond, I can station keep for you to show you how that would work, if you would like. Yeah, once you're close, let's close in a little bit. Once you're close, this blinking red light may be a bit of an annoyance. So you can come over to the encoder, 250, and then the next command would be 141 to make the approach lights, and 201 to make the panel display bright. And so now you can see the docking adapter, or TDA, is nice and bright. We can see we are a little nose up on it, so let's bring us down. Yeah, any preference to using computer instrumentation or visual? It's up to you guys if you want to see what the computer can do to sort of assist. Computer is probably going to load for another few minutes still. And yeah, that is a pretty sight. Although I do notice the Earth is incredibly bright, and I'm not a huge fan, so I may snap a photo and ask how to actually fix that. I think it's an issue with the post-processing, but I'm not entirely sure. Are you loaded yet? Nope. We'll get there, we'll get there. I kind of want to show off the computer controls, so. I do want to time skip just a little bit. And she's loaded. Okay, we could start the rendezvous program. Now, if we flip this to computer attitude, the needles will now show the proper attitude for docking on roll, pitch, and yaw. And what the IVIs display is they actually display your distance to the docking port. So we see that we need to go down 1 and forward a bit, which if we visually inspect makes sense. We also, it says we need to go right, but it's opposite because it's relative to the docking port. So we need to actually come left slightly. So the computer is really useful for getting a docking attitude, but outside of that, I don't find the IVIs particularly useful. I would just rather do it by eyesight, you know, used to that parallel parking, and this can't be much more difficult than that, so yeah, if you do your Y-point turns and your parallel parking in the middle of a city, you've got docking in space. Like, you move so slow, there's no possible way you could really mess this up. But yeah, we could see we're sort of 19 feet out, and visually that's great. Once we approach, we need to back off a little bit, slow our approach down so we don't break the target docking adapter, TDA. Ensure that our bus arm is on dock, which it is, and that's good. As we approach, again, we just want to slow her down gently until we are docked. And you'll know we're docked because, as this is a simulator, it teleports just like KSP. Very nice. Now we can turn off the fuel valves, turn off the computer, and get it to its idling program. Like so. And then we will also disable the approach lights on 1, 4, and then send 0 bit to disable those approach lights. And we can get our external docking lights off, bus arm safe, and we are docked. Congratulations. Yeah, how was that? Pretty good? What should we do? We've got not a whole lot of time for an EVA. So if we do an EVA, it should be now. What do you guys think? EVA? Extra vehicular activity? Take a step outside? Otherwise, option number 2 is actually to burn the engine here. Yes, this is an engine we can fire and control. So, up to you guys. Would you rather see an extravehicular activity or a burn of the Agena engine? Thank you very much. Thank you very much. I hope my docking skills were up to par. And while we're waiting to sort of get a pull, let's also just time skip to the daytime. So we want to have ample time. Go for EVA. All right. EVA. Start the spin. There is a mission which will simulate the spin. I do not have it enabled, though. Yeah, I don't have it enabled, because I wanted to actually, show off how the Agena works and stuff like that. So it's a thing we could do. So we got 1 vote for the spin, 1 vote for the EVA. We could run a simulation spin. But that'll be the last thing we do. So I'll put a pin in it for now. We got 1 vote for EVA. There we go. That's ample brightness for us. All right. EVA going once, going twice. And I think we are sold for EVA. Okay. Let's get our EVA checklist up. Cooling pumps on. Cryo quantity gauge off. And while we're here, let's just verify. Good. Our react reservoirs are good. H2 and O2 heaters on auto. Suit fan 1 and 2. Close cabin air recirc. Right O2 bottle open. AC power is on inertial guidance system. Acme bias is primary. FTR should be platform and rate. With FDAIs, we know that works. Propellant open. Propellant gauging off. RCS heaters off. Attitude control to pulse. Rate gyros primary. Radar off. Computer on. Nav in catch-up mode. Platform is on. Let's do orbit rate. Actually, no. Let's do sharp run forward. Voltimeter to main bus. Good, good, good. Communications. HF antenna retract off for 1 minute. UHF. UHF. UHF number 1. High frequency off. Keying will be continuous intercom push to talk. Antenna select will be adapter. TMs will be on command. And C-band beacons to command. Alright, final EVA preparations is to switch to secondary pump B. Gauging to O2. Cabin air recirc. RCS heaters on. External lights. Good. And depress egress. Record to continuous. Fuel valves closed. And vent. Good. Venting looks complete. Pulse orbit rate. Okay. Let's do the EVA. And yes, this is actually how the hatch opens. It's a little funny. Just a little bit. Alright, EVA. So face towards this craft, and will give us just a pulse aft, like so. There we are. We can see we only have 29 seconds of fuel, so we are being very sparse with it. This black tape here is actually to control how the radiators are boiling. There was fear that the radiators would work sort of too well, so they put this black tape here to reduce the effectiveness of the radiators. And do we have the EVA backpack? It's supposed to be here, but it's not. Interesting. Okay. Well, I will grab a photo of that, naturally. We'll just make a thrust towards it and see what we can't figure out. Maybe it's there, but not visually rendered. Hello, Juan. Juan P19. How goes? Unfortunately, it looks like we do not have... Oh, there it is. Hello. I can give the spacecraft a nice nudge. Alright, stabilize. And I can't remember if the simulated pilot will stabilize the craft, and it very much looks like it. Yeah, what do you guys think? Nice EVA. Nice walk outside. Agena's looking nice. Yes, the guy asking for help with Orbiter 2016. Yes, I did post the video with the installation instructions. That is up. And of course, if you're needing better explanation, because admittedly I didn't exactly show everything because I was not comfortable streaming my whole screen with my time and all my desktop applications, tax information, that sort of the thing I don't want to stream. Some of the stuff like how to unzip a file and stuff, I just sort of assume that as a Windows user that you would already know that. So I do take some liberties, and I apologize if that is what it would be causing confusion. Yes, no tether. Why tether? Tether is too safe. Yes, too safe. I like to fly freely. No, but the tether is actually not well, it is somewhat a safety net, and they did have to use the tether to pull themselves in before. But it's actually, believe it or not, it's actually a lifeline, quite literally. It supplies your life support. So no tether on here is, yes, unusual, but it's... I guess it's a, gamified simulator. Reentry is not known for being the most accurate in any shape of the matter. So yeah, it's suffice to say that is one EVA down. Let's take a step inside, and maybe then we can light the engine. All right, there we go. Close the hatch. Alright, post EVA. Close the hatch. Cabin vent is up. Close the O2 bottles. Bypass radiator. And repress. What do you guys say we do some orbital adjustments with the Agena engine? What do you guys think? What do you say we push our perigee, or what do you say we push our apogee out a little bit? Do an orbit with a highly elliptical orbit, and come back into the perigee and recircularize with the engine. What do you say? I think it could be really fun. I did do a tutorial on how to install the Saturn V add-on. It is up. If you would like, I will link it to you. Saturn V simulator, and let's here get shareable link, and let's go to OBS, and here you go. That'll be your installation tutorial. And if you need more of an explanation, I am able to redo and make a better explanation. Yeah. Okay. Looks like our pressure is good. Our O2 did take a hit from that, obviously, but we're good. Okay, so we'll close the repressurization knob now. Get our radiators back to flow. Switch back to the primary pump on the secondary reservoir. And we can start recircling air again. RCS heater can come off. And I believe that's everything. Let's save up on the squib batteries as well. We're going to be here for a while, so might as well. Get our gauging back on, check our H2, our O2 levels, all that looks good. Okay. Let's do a maneuver, shall we? So we are going to navigate to blunt end forward. All right, roger that. I'll see you later, Michael Martins. Thanks for stopping by. And I hope that I'm a little more vocal in today's stream than I was maybe last stream. Hope to be a little better. With someone's recommendation that I just get a little better at talking about things. So that's why I'm sort of practicing on this easier craft. But It is still fun despite being easier. There is nothing wrong with easy. Okay. What do you say we fire this engine, huh? Let's go for it. We are about at our apoapsis, so let's go to the Agena commands. We do need the radar on for this, because the encoder encodes the signals into the radar. So here we go. Let's do... Well, first we need to do attitude control. 1, 10, forward. So we will do 3, 6, 1. 3, 1, 0. 3, 2, 1. 401. 301. 3, 5, 1. And 3, 4, 1. At the completion of the maneuver, which we could see that we are pretty much already there, we can do 3, 4, 0. And let's burn. So we start with 571, 450, 'arm the engine. We can see the armed light is on. 521 for the vehicle management. So 521. And the engine is on. Now we just need to ignite it. So 5, 0, 1, and ignition. There she goes. Five, 0, 0, and cut off. 4, 5, 1. Engine arm off. 5, 2, 0. All right. Let's take a trip around, shall we? And I would venture to say that that is one successfully completed orbit. Let's get us back to sharp end forward. And there we go. Now then, same procedure as before. 571. 450. Arm the engine. 5, 2, 1. And 5, 0, 1. That will, of course, be a nice and tidy ignition. And then we can come up to a little bit closer to the apoapsis. That's pretty good. Okay. I think we're pretty much ready to ditch the craft now, so... let's close out. 5, 0, 0 is already good. 4, 5, 1. Engine stop. And 5, 2, 0. Okay, yep. I think that's pretty good. Let's go. Exterior lights to dock. Rate command. And disengage. Three, 6, 0. Three, 1, 0. 3, 2, 0. 4, 0, 1. 3, 0, 1. 3, 5, 1. And 3, 4. I'm curious to see if that'll actually maneuver the Agena. Alright. Maybe it's already in sharpen forward. Let's try 3, 6, 1. And then 3, 2, 1. And then 3, 4, 1. Just curious to see if this will maneuver. But it does not look like it, unfortunately. Anyways, let's conclude our separation burn. Take it a little up. And a little more aft. With a little bit of left. Okay. Circularize at the periapsis.
Roger, DCS.
And that is expected to occur at 6 hours, 31 minutes. We are very close to it. And 30 seconds. Go. Another cool trick you can do is actually zero out your left and right by actually using attitude and then just only burning by holding down one thruster. A little nifty trick that not many people know about. And that's it. And we could raise our apogee slightly here. There we go. And bring that down. Perfect. Alright. Let's bring us home, shall we? So we will retro at next apogee. 1 hour, 23 minutes, and 19 seconds. So we can check core 19 for that. 4, 9, 8, and counting down. Cool. And now we can go to our pre-launch program, which is our idling program, since we are not going to do any more maneuvers. And let's begin that pre-retro checklist. So we can now close the TR time to retro, 256 seconds. That's good. That's good. And yep, we need to go blunt and forward. Our event timer up to 20 minutes. Excuse me, that is exactly the wrong direction. $20 minutes left. O2 bottle open. And we can open the H2O and OAMS heaters. C-band, reentry, continuous. So we got our reentry C-band beacon on. TMs are going to be real-time and acquire. And let's do a battery test. Looks good. 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 And good. No battery failures this time. That's good news. Now we can open the calibrator, Agena power and control. and a secondary O2 bottle for entry. And we could also disable the Agena squibs, because why not? Alright, now we just need to wait for core 19 to read 1200. So we will skip time. And I'm just going to use my auto clicker so you guys don't need to hear the spam clicking. It's a much better experience. So we may get that. And we could stop that from happening by simply doing that and that. But we should keep these on. Okay, 1 minute from now, roughly. "13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, start." Perfect. And get the computer to the reentry program. And give us a reset too. Get those lights out of the way. Now we just need to wait for the computer to finish loading. And while we wait, let's queue up the 256 to retro. Computer's loaded. Start. And once we are at the time desired, the lights will go amber. So let's, just before that, let's do squib batteries online so we don't forget. And this is my absolute favorite part of any mission. Here's the lights. So we need to get the battery power on. That's good. RCS propellant motor valves A and B open. RCS A. Oops, sorry, this to RCS A. Record, continuous, cryo quantity off. Platform, attitude, high. Rate command reentry. Primary ohms off. A and B to Acme. Let's indicate retro attitude. There we go. Activate RCS. Retro power armed. And let's go to retro attitude. Maneuvering on RCS, reentry control system. Platform, attitude, rate high. High frequency TR off. Primary pumps and secondary pumps off. radiator to bypass. And close that. Start 1 minute to retro checklist. The moment we've all been waiting for. T-minus 1 minute. Separate ohms line. Separate the electrical system. And staging. There she goes. T-minus 30 seconds. We'll need to arm the retro rockets. 3, 2, 1, mark. Arm the retro rockets. Yes. That was exactly not what I wanted to do. Somehow flipping the lid also pushed a button. Yay for me. We have an early fire of the retro. But that's okay. Platform to blunt and forward. Already is. Good stuff. Retrojet arm. And staging. Alright, post-retro jettison. Computer attitude. Low. CS power B off. Boost insert and retro sequence circuit breakers open. Cryo, H2, and O2 heater circuit breakers. Ohms control propellant circuit breaker. Open. Fuel cell control circuit breakers. Open. Tape recorder control. Open. And stow the fuel cell switches. Good. Just finished the last essay assignment of the year, and it's now time to relax. Oh, yes. Well, welcome. I'm very happy to provide ASMR. We've got lots of switch flipping. Well, you sort of came in at the end. We did a rendezvous and docking, an EVA. We ignited the Agena engine. But, just for you, we can extend the duration of the stream. I'll do a Mercury mission. Yes, that'll be good. You can get a little ASMR in there. Right? Computer attitude. Landing squib. Arm. We had a 10-second accidental ignition because I did that on accident. You shouldn't be able to push the button while the guard's closed, but it happens. It happens. We will not complain. We will still survive. So let's make sure we're entering the atmosphere with a proper attitude here. Let's give us a nice roll. Done. Yeah, as we could see, the reentry control system is not exactly the most precise, but it doesn't need to be, because once we hit the atmosphere, we don't need pitch and yaw control anymore. We only need roll. It self-stabilizes. Kind of like an arrow. Actually, exactly like an arrow. It's the same principle. There we go. Proper attitude for entry. Perfect. Again, heads up. And now is the point where I would sort of click off the lights. And you'll see why. It's about to get highly entertaining. Here's the atmosphere. The drag is stabilizing us. Yeah, I figured as much. Okay. Yeah, that looks really cool. I hope we're not entering overland. Oh, cool. Nice. That is the thing you can do in Reentry now. You used to not be able to land on land. The whole Earth would turn to water, but now you can actually land on land. So you have to be very careful of your retro times now. So what we're doing here for entry is we're just looking at this roll needle, and if we ever need to, the computer tells us which way we need to be rolled. So we just always focus on the roll needle. Pitch and yaw are self-stabilized by the atmosphere. So you'll know when things will start to get real shaky very, very suddenly. It'll look cool. So we can see we're just kissing the atmosphere right now, 0.05 Gs. And very shortly that will be increasing. If we wanted to speed it up, we could roll over, but right now the computer tells us we need to face this direction, so we will face this direction. That is exactly what we'll do. Oh, here we go. Looks like we're starting to get a little G build up. We're up to half a G, 0.5. One G. And here it comes. I trust the computer. Come on, you're not gonna do this to me. Alright, there we go. There we go. Good, good. 15 Gs and we break up, so ooh, it's very rough. Alright, come on. Try to alleviate. Yeah, we need to go this direction. Okay. And there we go. Alright. We've broken atmosphere without breaking up. Good. High altitude drogue. Checklist. Landing. Altitude drogue. D-ring is uncovered. Propellant motor valves closed. O2 rate high on at 27,000. Which I think is good. Okay. Now we just need to wait for the 10.6. Ooh, wow, and it does look like our entry is a good one. $104. I've done better. It was that 10-second early retro. Very unfortunate, but it is what it is. Okay, good. I was gonna say that. Better not. There we go. Main chute is green. Landing attitude. There we go. If you're wondering how that works, it pulls on the antenna, one of the antenna cables, making tension, changing the attitude of the craft. Okay. After main deploy, attitude indicator circuit breakers. Open. Rescue beacon. Without light. Good. Acme bias power off. RCS heaters off. Scan heater off. Computer pre-launch. Computer power off. Platform off. Rate gyros off. AC off. RCS circuit breakers open. RCS control power off. Acme control. Excuse me, Acme control. And now we just comfortably wait for splash. Yeah, so just basic power down. And you know what, since we don't have the ohms attached anymore, don't need that. We don't need the RCS squibs. We don't need that either. Don't need that. Don't need that or that. Or that. Or that, really. Don't need that or that. Or that. Or that. And we'll stand by for the splish. There we go. $13 max Gs. That's it. All right. And it's been a while. Let's go back to the craft I first started with. This is the place everyone first learns what to do. Yes, the splish and splashed. Yes. I hope that entry was satisfying. It is the place of humble beginnings. That flashlight texture is a little broken, but we will ignore that. Oh man, this, I gotta say, this really takes me back. This really takes me back. Okay. Get the batteries turned on. There we go. And for our own sanity, some cabin lights. Good stuff. Okay. All of the circuit breakers, fuses rather, we'll move these to the number 1 position for primary on. Squibs off. Auto retro jet arm. Norm auto norm. In. Retro delay instantaneous. Photo lights on. Cabin lights both. Telemetry low frequency on. Rescue aids and auto. Launch control switch off. All of these in and guarded and auto. Fuel's at 100%. Satellite clock is functioning and shows correct time of day. Attitude rates are centered and attitude positions are good. Cabin pressure is good. Temperature is good. Sensor temperature is good. Evaporator vent temperature is good. Suit environment's good. O2 quantity is good. Cabin O2 makeup is good. Suit fan switch to normal already is. Cabin fan switch to normal. DC volts main. Ammeter is off. ASCS standby bus. Nope. Normal bus on. Standby battery on. Isolated on standby. AC should be 115 volts. And relatively good. There. Vox off. UHF-DF normal. UHF select high power. Transmit switch off. Beacons on ground command. All annunciator audio tone switches to tone. Warning lights are bright. Emergency O2 switch is normal. And temperatures to mark. And spin up the gyros. Data T minus 40 minutes with an abort check. We're on this little itty bitty suborbital rocket. Look at how small that is. It's cute compared to the Apollo. Alright. Ammeter normal. Capsule squibs armed. DC selector isolated bus. And request abort capability test. Spike and amps, good. Abort light on. Abort light off. Amps to 0, good. Abbreviated interior inspection. Squib is armed. Auto retrograde is armed. All these are number 1. All those are number 1. Retro delay will go to normal now. Rescue switch is auto. I also realized I should time skip down to 20 minutes for this. There we go. Auto, auto, auto. Auto, auto, auto. Good. Good and good. Good, good, good. Good, 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 good. Inlet valve power normal. Audio bus normal. Fans AC normal. Oh yeah, check this out. Oh, that doesn't turn off the power anymore. Ah, rats. It's probably because we're on ground support equipment, now that I think about it. Okay, Vox power off, UHF-DF normal, select power off, and beacon to continuous. At T minus 10 minutes. Switching to full internal power. Good. We've got our amps. Isolated and standby off. Okay, final checks. Launch control on. Transmitting UHF. Monitor that. Armed and armed. Okay, we are ready. $15, $12,
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
lift off.
All right, lift off and the clock has started. Yes, sir. Reading you loud and clear. I'll tell you.
Look at it go. Okay, good. We got cabin pressure is decreasing nominally. Sensor temp's good. Steam vent temp's good. Soot environment's good.
Cabin pressure is holding at 5.5. Cabin holding at 5.5. I can understand. Cabin holding at
5.5. Cabin valves remain sealed. Cabin O2 is good. Oxygen quantity is good. All batteries are good. AC bus is good. Altimeter is good. ROD is good. Fuel is good. Acceleration is good. Standing by for cutoff. Cut off. Tower jet is processing.
Cut off. Tower jettison green. Now.
Cap set.
Cap step is green.
And the turnaround has started. Okay. Executing retro checklists immediately. Auto retro jet switch off. Low. Retro jettison fuse off. Attitude select is retro. Auto retro jet switch. Yeah, that's already off. Good, 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 good. Okay, let's do some controls tests. Let's test auto control, but manual roll. Looking good. And pitch and yaw. Good. Put that back in. Let's try some yaw action. It's looking good here. And autopilot brought roll right back to where it needs to be. Try some good old pitching action. Yeah, it's looking really good. Okay. Now let's go fly-by-wire. Do the same test. Roll is good. Pitch is good. Yaw is good. Retro sequence has started. Aux roll is good. Pitch is good. Yaw is good. Alright, let's get back into attitude for retro. There she goes. And cut off. Auto retro jet is armed. Jet retro fuse on. Standing by for retro jettison. Retrojet. Attitude select, reentry. Okay. Looks good. Emergency drogue deploy goes to off. Until after the flames are gone. I must say, ASCS is doing a terrible job at holding attitude. Didn't want to maintain on my side for too long. That would have been very deadly for us. We are on radar altimeter now, barometric altimeter now. So let's get the emergency drogue deploy fuse on. Cabin pressure is decreasing, or increasing, rather, as we are coming down through the atmosphere. Here comes the drogue. And snorkel. Alright, waiting for mains to green. UHFDF will be on real time. And then we'll water seal the pressure regulator. There we go. Main shoot. Here comes the landing bag. Real time. Water seal pressure regulator. And that is all she wrote. Funny thing you can do. anyways, I think with that, as soon as we splash down, I'm going to end it there. So I thank you all for watching, and I hope you guys have a fantastic and lovely day. With the conclusion of Gemini out of the way, I think we are ready to do our Apollo 9 launch again. For those of you that don't know, we had an S4B ignition failure and flame out, so we had to do a mode 2 abort, unfortunately. But it was pretty cool. It was the first time I ever done an abort in like the over 500 hours that I've been there, so it was really interesting to actually need to do an abort. So if you haven't watched that, then watch it. And another cool video I recommend is the Apollo 8 what 6.5 Gs feel like, because the tunnel vision, the compression into your seat is absolutely crazy. So with that, I'm gonna go silent now, and I bid you all adieu.